Hello world! In today's video, we'll be diving into how to rebase and squash using Sourcetree. We'll cover a simple rebase and squash using interactive rebase, a more complex interactive rebase and squash with selective squashing and conflict resolution, and tips for rebasing remote branches. With that out of the way, let's get rebasing. Before you start any rebase, make sure you've pulled the latest version of the branch you want to rebase against. For example, I'd like to rebase my feature branch on develop here. I've already fetched and pulled the latest changes, but if you're new to Sourcetree, just click fetch and pull to update your branches. Let's take note of the last commit on develop, which was on the 13th of April. This means when we rebase, all the commits from our feature branch should appear on the top of this one. Switching over to my feature branch, we can see that the last commit was on the 5th of April. Compared to develop, our feature branch is missing the 13th of April commit. We can confirm this by viewing all branches, like so. See how develop is ahead on the timeline? That makes our feature branch a perfect candidate for rebasing. To keep things simple, I'll switch back to the current branch view. The easiest way to rebase is to right-click on the branch you want to rebase against, in this case, develop, and choose Rebase Current Changes onto Develop, and confirm. And that's it. If we check the Git history now, the April 13 commit from develop is visible as the new base of our feature branch. The top commit, now dated as April 26, is actually our original April 5 commit. Looks like we branched off develop recently, doesn't it? If you're wondering why the older commit now shows a newer date, here's the lowdown. Every commit has two dates. An author date, April 5, and a commit date, April 26. The commit date updates during the rebase, which is why it appears at the top of the history. Pretty cool, huh? Next up, a simple rebase and squash. In this scenario, our feature branch has two commits ready to squash. Viewing all branches again, we can see develop is ahead. To trigger an interactive rebase, right-click on the latest commit on develop and choose rebase children of #commit interactively. Interactive rebases allows us to perform squashes. Now we're in the interactive rebase view, where we can squash commits. I'll show you two ways. First is drag and drop. Simply drag the commit you want to squash onto another. Want to undo? Just hit reset. Squash with previous. Select the topmost commit and click squash with previous. Now let's observe what happens to the commit message when squashing. First, note the last message. Then perform the squash. It might look like the message was overridden, but if you click Edit Message, you'll see the original message is at the bottom. You can modify the combined message however you like. I'll remove the generated parts as an example. Then click OK. We won't see the update just yet, but once we confirm the rebase and squash, and switch back to our current branch view, voila! One commit now contains both messages, dated April 26, with develop as the new base. How are you going so far? Have you managed to perform a rebase successfully? Drop your questions in the comments below if you have any issues. I'm here to help. In the meantime, ready to tackle something trickier? Let's look at how we can tackle a more complex rebase and squash. Here we have 4 commits after the April 13 develop commit. 2 of them relate to a H3 element, so we'll squash those and leave the others. Let's trigger the interactive rebase now by selecting View All Branches. Find Develop, right-click, and choose Rebase Children of interactively. I'll drag the top H3 commit onto the previous one and leave the rest. Then I'll edit the combined message, remove the generated bits, and confirm. Uh-oh, our first conflict. No worries. Resolving conflicts during a rebase is easy once you know how. Close the conflict screens to see what's going on. Nice, just one file. During a rebase, the head marker represents the parent branch, develop in this case, and the incoming changes are from the child branch, which is our feature branch. This is the reverse of what you might be used to when addressing a merge conflict, so keep that in mind. I want to keep the changes from my feature branch, so I'll resolve the conflict using theirs in Sourcetree. But feel free to use whatever method you prefer. Once resolved, stage the file, but don't commit yet. Under the Actions tab in Sourcetree, choose Continue Rebase. Gah! Another conflict! Stay calm. This is normal. You'll need to resolve each conflict for every file affected. Just follow the same process. Resolve. Stage, but don't commit. Once done, go back to Actions and choose Continue Rebase. Now we get a chance to amend the commit message. You'll see a note saying, lines starting with hash will be ignored. But in Sourcetree, some of those lines sneak into the final message. I like to remove the first two hash lines and the one between the messages, just to be safe. If you don't mind them, feel free to leave them. Click OK to finish. When the loading bar turns green, click Show Full Output, then close. Back to the current branch view. We can see the first and last commits remain with updated commit dates. The middle commit is now a combination of the two commits we squashed with the updated commit date, and the base is now developed. And that's how you perform a complex rebase and squash. If you've already pushed your branch remotely, then rebased or squashed the same branch, a normal push after your rebase will fail. This is because Git sees a different history and assumes you're missing commits. So it rejects the push and prompts you to pull before pushing. But don't pull. Doing so will undo your rebase and squash, undoing all your hard work. Instead, enable force push in Sourcetree. To do that, click Tools, then find Options, find and click Git, then enable force push, and use safe force push. What's the difference, I hear you ask? A force push overrides history. It's risky if someone else pushes changes you don't have. Safe force push protects against that by preventing accidental overrides of others' changes. Once enabled, check the force push box just before you confirm your push of your rebase branch. And that concludes the tutorial on performing a Git Rebase and Squash using Sourcetree. I hope you found this helpful. If you want to explore more content from me, be sure to like, subscribe, and click that notification bell to stay updated. Until then, this is Micro, logging out.